Hi guys, so this is Chanya and welcome to Math Learning Hub, a hub for everybody who loves math. So today we will be talking about the Pythagorean theorem. So let's just jump in and get started. So first of all, since the Pythagorean theorem relates to right triangles, we should define what a right triangle is. So a right triangle is a triangle with one right angle. So what is a right angle? So in case you need a refresher, a right angle is an angle with a measure of 90 degrees. It is denoted by the square here. This means that this angle measures 90 degrees and is right angle. Okay, so now for the sides of the right triangle, the longest side is called the hypotenuse. In this case, it would be the side C here. This is the longest side of this right triangle. Another more formal definition is that the hypotenuse is the side opposite the right angle here. Now for the other two sides. So the other two sides are called legs. So that would be this side and this side. And you can also see here, they have the labels hypotenuse, leg, and leg, right? So if you know two sides of a right triangle, you can find the third side using the Pythagorean theorem. So suppose you know A, or I should actually highlight it here. So A and B, suppose you know these two, you can find C. If you know C and B, you can find A using this theorem. And this theorem is that A squared plus B squared equals C squared. In other words, the length of the side A times itself plus the length of the side B times itself equals the length of the side C times itself. Okay. So sometimes it may take a little bit of time to solve the Pythagorean theorem, but luckily there are some well-known right triangles which have whole number side lengths. And these are known as Pythagorean triplets. And some examples are shown below. And after I show you the Pythagorean triplets, I will show you applications of the Pythagorean theorem on these problems. Okay, so just for the Pythagorean triplets. So one example of this is 3, 4, 5. So you might be wondering, what does 3, 4, 5 mean? Well, 3, the first number in the triplet, is the length of the first leg. So I'm going to call this L1. Second number in the triplet is the length of the second leg. So I'm going to call it L2, which stands for leg 2. And then the third number in the triplet is just the length of the hypotenuse, so which I'm going to label H here. So in this case, with a triangle of side lengths 3, 4, and 5, 3 would be the shortest leg, 4 would be the other leg, and 5 would be the hypotenuse. So let's see if this triplet satisfies the Pythagorean theorem, right? So taking into account that 3 is your first leg, and A, if you look at this triangle, A represents one of your legs of the triangle in the Pythagorean theorem. I'm going to plug in 3 for A. So let's see. So A squared, which would be 3 squared, because we already established that 3 is A, plus the other leg squared, right? The other leg squared, well, what's the other leg here? The other leg here is 4. So I'm going to plug 4 in for B because it's the other leg of the right triangle. So 3 squared plus 4 squared equals the hypotenuse squared. So hypotenuse here is 5, and the hypotenuse here is represented by C. So I'm going to plug in 5 for C. So now using the Pythagorean theorem and using this set of 3 numbers, we get this expression, right? Now I'm going to evaluate if it's true. So now let's see, what is 3 squared? So 3 squared is 3 times 3, which is 9, plus 4 squared, which is 4 times 4, which is 16, is equal to 5 squared, which is 5 times 5, which is 25. And you can clearly see that this is true. So we've tested one Pythagorean triplet. I don't think it's necessary to test the others because basically Pythagorean triplets are very helpful to remember because they're whole number values that always satisfy the Pythagorean theorem. In other words, A squared plus B squared equals C squared is true for like the 3, 4, 5 triplet, the 5, 12, 13 triplet, 7, 24, 25 triplet, 8, 15, 17 triplet, and basically all of these numbers here. One quick note, you can manipulate Pythagorean triplets by like scaling up or scaling down. For instance, if you take 10, 24, 26, for example, if you know that 5, 12, 13 satisfies the Pythagorean theorem, you notice that 10, 24, 26 is basically all the side lengths multiplied by 2. Therefore, it must satisfy the Pythagorean theorem as well, since you're only scaling the sides and you're not changing the ratio of the sides in the triangle. And this is, of course, illustrated here. The resulting three numbers will always be a triple. Okay, so now that's enough talk about Pythagorean triplets. I'm going to go straight to practice. So find the hypotenuse of a right triangle with legs of 6 and 8. So I encourage you to pause this video and try to figure this out. Okay, so if you're ready, I'll give the answer now. So basically, you notice that your legs are 6 and 8. So you plug this into Pythagorean theorem, right? So you take your first leg, which is 6 squared. So you take your first leg square plus your other leg, which is 8 squared, is equal to your hypotenuse, which we don't know. But I'm going to make this C. I'm going to represent this by C, right? Because that's how it's represented in the theorem. So 6 squared plus 8 squared equals C squared. And you want to solve for C because you want the hypotenuse, which is represented by C. So now I think the best thing to do would be simplify this side, right? So what is this? 6 squared equals 36, which is 6 times 6, plus 8 squared equals 8 times 8, which is 64. That's still equal to C squared, right? So if you simplify this here, 36 plus 64 is just 100. So you get 100 equals C squared. So therefore, if you square root both sides, then C is equal to square root of 100, which is 10. So C is equal to 10. So technically when you square root it, it can basically be like 10 or negative 10, except here you know that C cannot be a negative value since it's a side length, right? Side lengths can't be negative. So therefore the only one that makes sense is that C equals 10. And C is what you're solving for, which is the hypotenuse. That should be your answer for this question. But see, this is where Pythagorean triplets pretty come in handy. Because if you notice, if you know the 3, 4, 5 triplet, and you recognize that 6, 8, 10 is the 3, 4, 5 triplet, but with all the side lengths multiplied by 2, when you see 6 and 8, and you know to write a triangle, you could just go, boom, this is 10, right? So this is why Pythagorean triplets are very helpful. So now I'm going to move on to the next problem. Find the other leg of right triangle with hypotenuse of 17 and one leg is 8. So I also can encourage you to pause this video to find out the answer. Okay, then if y'all are ready, then I will go over it. So let's see, you have the hypotenuse in this case and one leg. So let's put this into the formula, right? So suppose you have one leg, which is 8. I'm going to plug this in for A, since A represents one of the legs in our theorem. Right, so 8 squared, because 8 is A, right? So 8 squared plus the other leg squared. Well, we don't know what the other leg is. So I'm just gonna represent this by B. So B squared. We're trying to solve for B because we don't know this value, right? We need to find the other leg. And this is all equal to C squared. Well, what is C? C here is your hypotenuse, and your hypotenuse is 17. So you get 17 squared. Okay, so 8 squared plus B squared equals 17 squared. So now I'm just going to simplify all the squared things in this expression. So let's see, 8 squared is 64, right? 8 times 8, which is 64, plus, you still don't know what B squared is, but you do know what 17 squared is. So I'd highly recommend you memorize squares up until maybe 20. So for my memorization, I know that 17 squared is basically 289. Okay, so now subtracting 64 from both sides, you get that, let's see, b squared is equal to 289 minus 64, which is 225, right? And this is again where your squares come handy because I recognize that 225 is 15 times 15. So therefore, when I square root both sides, I get that b is equal to 15, right? 15. Again, b cannot be negative 15, which is another possible answer because of the square root. Because that wouldn't make sense in real life because side lengths cannot be negative. So therefore, the other leg length should be 15 here. Again, if you know your Pythagorean triplets, if you know that 8, 15, 17 is a Pythagorean triplet, you can basically go, boom, the answer is 15 because you have a hypotenuse of 17 and a leg of 8. So this is why I can't emphasize enough how important it is to memorize these triplets. If you don't know them, you can still use this formula. It works universally for right triangles. However, it's going to be considerably slower than if you can just, go to that conclusion in your head. So that should be it for today for the Pythagorean theorem. And I hope you guys enjoyed this video. And if you want to see more content like this, then please make sure to subscribe to this channel and follow for more. Yeah, thank you. It's been a pleasure teaching you. This has been Chanya and Math Learning Hub, and bye.